There's a mysterious zone far out in our solar system. It's a region of ice worlds, some solitary, some with moons. Their names may be unfamiliar: Eris, Makemake, Haumea, but they hold clues to all our origins. And the first of these worlds, and the one we'll reach in 2015, is the king of the Kuiper Belt, Pluto. The long journey of NASA's New Horizons mission began in 2006 aboard America's biggest, baddest rocket, tricked out with every conceivable booster.
We built a very light spacecraft and bought a very large launch vehicle, and the combination is ferocious.
But in some sense, it all began in 1930 with Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, but willing to spend long hours scanning star fields to find a moving point of light, humanity's first glimpse of Pluto. The dream of actually getting to Pluto began with a 6-year-old boy in love with science, who grew up to lead a team of brilliant researchers and engineers with dogged persistence through decades of planning and building and testing. A race against time just to get to the launch pad.
Exploring the outer solar system, because it's so far, takes a lot of time. It requires a lot of patience, a lot of dedication, a lot of perseverance, but it's the frontier.
Assuming all goes well at Pluto, NASA may choose to extend the adventure further out into the Kuiper Belt, the solar system's mysterious third zone.
This is maybe the one chance in my lifetime that we're going to get a spacecraft out there and look up close at one of these Kuiper Belt objects.
December 6, 2014.
We have an all wake up with the New Horizons spacecraft.
New Horizons wakes up for the last time from hibernation.
New Horizons is speeding towards Pluto at a phenomenal rate, and we can't wait for it to get there.
January 27, 2015, 6 months of approach science begins. July 14, 2015, New Horizons' long journey, 3 billion miles, 9 years in flight, and 85 years of speculation about Pluto, climaxes in one day of close approach and flyby.
You know, we're rounding third base and we're headed home.
The dream, the adventure, the promise of discovery. That's what makes 2015 the year of Pluto. Studying Pluto and its neighbors from Earth is one of the toughest challenges in astronomy. It takes the largest telescopes and most advanced instrumentation on the planet. And it's tough even for the Hubble Space Telescope. And it takes time, from the discovery of Pluto in 1930 to NASA approving the New Horizons mission in 2001 to arriving at the planet in 2015. It's been 85 years, and time passing is definitely an actor in our story. But it's the combination of human skill, cutting-edge image processing, and sheer bloody-minded persistence that has resulted in the most important discoveries. And that's a tale as true today as back in 1930, when Pluto was first found by Clyde Tombaugh. In 2011, at the SETI Institute near San Francisco, Mark Showalter used Hubble data to discover 2 new moons around Pluto, although he was actually looking for possible rings. Showalter has found rings associated with small moons around other planets.
And that was kind of the motivation for checking out Pluto. It's got 2 little satellites. Satellites raise clouds of dust. Let's see what might be there.
It's easy to take artistic license to show what Pluto's rings might look like. In reality, it's incredibly hard to see faint objects against the dense background star field and the glare from Pluto and its large moon, Charon.
We came up with this trick where you take the images and then you rotate the camera 90 degrees, you take more images, and if you do that all just right, you can do this thing where all that glare cancels out, and what we're left with is just the rings. We could think of it as a stack of images. Think of it as like a cube looking down. So let's turn it on its side. So now if we start peeling off the layers and looking downward through the stack, things suddenly become much, much cleaner. For example, Hydra and Nix show up very, very cleanly. But the thing that immediately caught my eye was this little dot. right there. It's not a perfectly sharp hot pixel like over here, and that's what made it pretty convincing to me that we had seen a very small moon of Pluto that nobody had seen before.
To be sure you've detected a real moon or planet, you have to show it's moving, unlike the background stars.
The thing that makes moons distinctive is if we come back later, they'd all have shifted because they all orbit the central planet. This required a great deal of patience to then wait about 6 days until we got our next set of observations of the Pluto system. Sure enough, the object was still there. It had moved by just about the right amount to be something orbiting Pluto, and we knew we had a moon.
Next year, Showalter and colleagues went back and built on lessons learned to see what else might be there. Summer 2012. Now, Mark had 15 more days of Hubble observations.
Now, what you can see here are 3 time steps. Each of those time steps is actually about 45 minutes of data. That means it's long enough that the little moons move. It's moving back and forth in this 3-frame sequence. Hydra is moving, Nix is moving. I mean, it doesn't take a rocket scientist to say that that looks like a little moon of Pluto. It's moving just the way the others are. They're all going around the planet in the same direction. And so it was just a couple of weeks later that we made the announcement that the 5th moon had been discovered.
Patience, persistence, ingenuity. That was exactly what led to the discovery of Pluto back in 1930. In Kansas in the 1920s, Clyde Tombaugh grew up in hard times and built telescopes using leftover farm implements. To check the accuracy of his best telescope, he sent drawings of Mars and Jupiter to the Lowell Observatory in Flagstaff, Arizona. They were looking for staff, and he was hired. Along with observing the stars, he stoked the furnace and shoveled snow. But one assignment made history. Day after day, he'd use this machine, known as a blink comparator, to look for anything in his images that moved. It was tedious, painstaking work, but on plates taken on January 23rd and 29th and analyzed in February, he saw a small dot that did move against the fixed stars. Announcing the results after careful confirmation, the observatory made it easy to find the new planet by adding arrows.
This is an incredible work of observational astronomy, and having done something similar but with much more powerful tools, I can really appreciate his achievement.
For decades, Pluto remained, more or less, a point of light. But in the mid-70s, Dale Cruikshank and colleagues attached cameras with infrared filters to a telescope at Kitt Peak.
Detectors or sensors had been improved, and larger telescopes had become available. Well, we did that work in 1976 and found evidence for frozen methane on Pluto's surface. It was several years later that we found the evidence for the other ices.
In 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the U.S. Naval Observatory in Flagstaff. Christie noted an elongation to the north of Pluto. 1 month later, the bump had disappeared. From this and other evidence, they concluded that Pluto, like Earth, had a moon, Charon. From eclipses between Pluto and Charon occurring in the 1980s, astronomers calculated that the moon was almost half the size of its parent body, so large that both objects spin around their mutual center of gravity, outside Pluto. Pluto and Charon were the first double dwarf planet combo discovered in our solar system. Using the basic physics of their orbits and the distance between them, astronomers could calculate their mass and size. Pluto was a little smaller than Earth's moon, about 1,500 miles in diameter, and had only 1/10 its mass. Between 1985 and 1990, astronomers were in luck. As Pluto and Charon orbited their mutual center of gravity, each passed in turn in front of the other. The so-called mutual events allowed astronomers like Mark Bowie to capture the changing patterns of light. Patiently, Bowie created a map of Pluto. Pluto turned out to have one of the 2 most contrasty surfaces in the entire solar system. In the mid-90s, Bowie and Alan Stern used the Hubble Space Telescope to make the first direct images of Pluto's surface.
And it's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2005, Hal Weaver and Alan Stern used the Hubble for another close-up look at Pluto and Charon. They discovered two small, dim moons where only Charon had been seen before. Now we know from Mark Showalter's work that there are two more moons, making the current total of 5, and that Pluto is a genuine many-planetary system. From its size and orbit, astronomers estimated that Pluto is perhaps 70% rock and 30% ice. That makes it one of the largest of a whole new class of objects, the ice dwarf planets, making up what's known as the Kuiper Belt. This region is named for Gerhard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk of other worlds beyond them. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive CCDs, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaugh's work. Take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, QB1, did just that. It was only a few hundred kilometers across, 10 times smaller than Pluto, but still huge compared to a comet. Since then, teams of astronomers have found around 2,000 KBOs. Informed by cutting-edge astronomy, but with a fair dose of artistic license, let's take a trip through this third zone of our solar system.
We used to think of the solar system consisting of two different types of planets. The planets we call the terrestrial planets, which are Earth-like planets. That would be Mercury, Venus, Earth, and Mars.
Next out, the asteroid belt. Fragments of worlds smashed to pieces by gravitation and collisions. Then come the 4 gas giants. Jupiter and its moons. Saturn with its magnificent rings. Uranus, also ringed. And Neptune.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a third type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
By July 2015, we'll know for sure what Pluto and its moons look like, and that will provide breakthrough information on all those other ice dwarf planets, the most numerous planetary objects in the entire solar system that make up the Kuiper Belt. Actually, the Kuiper Belt is more like a donut, bulging up above and down below the ecliptic where most of the planets move.